Recording, Langbor MDF, January 19th. Dougal Gillis, Technical Director, Langbor MDF. This is Dougal's lab right here. There's the GAN system. And what we're going to do is step outside, and Dougal's going to give you a brief description of the medium density fiberboard process here at Langbor MDF in Willacoochee, Georgia. And then Dougal Gillis is going to come back in and tell you a little bit about how he's used the GAN for monitoring internal bond. Dougal, tell me a little bit about the press. You have to talk kind of loud here with this.
Right there we got a 20 opening daylight press. We're running, making fiberboard, medium density fiberboard. We're using only pine, and we're using pine chips and shavings to make the board. The board is, or the chips and the shavings are mixed together and ground up and made into a mat that you see going down the line. And we run it into the press. And the press will be heated to around 350. And according to the thickness, in a few minutes we'll have a fat panel.
And what, for the people that aren't familiar with MDF, what is medium density fiberboard used for mostly?
Making furniture, cabinets, doors, entertainment centers, tables, most of your interior buildings.
Is this a typical MDF plant?
Yes. Typical.
Okay. And this is back to the forming line, and then there's another section of the plant which is milling and drying, or where essentially the wood is refined into fiber, and then there's a press control room located above the press. We're going to step back into Dougal's office now, and he's going to briefly describe how he's used the GAN.
This system is helping us to predict and run the plant. We're looking for a certain IP for a certain size board or a certain grade of board. The green you see here are predictions that the GAN system is making and estimating that our IB should be in this area. The dots, the red dots, are the actual IBs where we put our test, and it is coming out within just a few pounds, if not right on. And this will enable us, by taking this information, and if we know which way it's going ahead of time and can take it and use it, we can lower the cost of making the board by dropping resin, adding time, and the board will still have the same quality. Because when we make our IBs and we can be this consistent, it'll allow us to lower our usage and our raw materials, and that includes resin.
Dougal, why did you have a big jump there in the graph? Is that another product?
This was a product change where we were going from an industrial board to a specialty product. We slowed the press down, we slowed time down, we added resin. The system saw it and predicted us an IB here, and the prediction was right on line there. Here our actual board was a little less, but we're right back in line with where we're at. And there we're changing time, and by the prediction shows that we were going to go down on IB, and we did.
Will you take internal bond away if you're making more internal bond than you need? How will you take that away? In other words,
we'll take out resin, and we can speed up. If we speed up, we gain production, and that's where your money's at, is production.
Okay, good. Okay, Dougal, thank you very much.
You're welcome.